All right, welcome back. We are going to get started here on learning about special right triangles and how we can use special right triangles to help us solve triangles. So we're going to be on page 78 and 79 of our notebook here. So if you want to join us there. The other thing you will need, and I will attach a video or a document on how to do this, is you are going to need a square and an equilateral triangle. I have these on two different colored papers, but you will just need those for this lesson or for the notes that I'm going to do. So let me share my document camera here and we will get started. Okay, again, we are on page 78 and 79. And the title for each page on 78, on page 78, we're going to title this 45, 45, 90 special right triangle. And on page 79, we're going to label it 30, 60, 90 special right triangle. And the reason we look at these special right triangles is there are some unique ratios with them already. So if I can memorize those ratios, I can find the side lengths and the angle measurements very quickly. So on page 78, we're going to take the square here, and I'm just going to tape the square in. Now, I like to line it up on the lines, and I'm just going to put a piece of tape here and a piece of tape at the top. And you can kind of see the direction my flap is there. With the equilateral triangle, we're going to put that on page 78. But before I do that, I'm going to take it and I'm going to fold it in half. Might be a little bit tricky to do because there are a few folds on it already, but just do your best. Okay, and it didn't quite match up, so I'm just going to trim it down to size. Okay, so we've got that triangle right there. I'll put two pieces of tape on it. I'm going to put a piece of tape right here and a piece of tape down here on this half right there. Okay. All right. The next thing that we want to do is just, I'll take a marker and I will trace around these shapes. Now you notice I didn't go over the tape portion because it's just going to rub off anyway. And you really only have to go over the flat part. All right, let's begin talking through the square here. So my goal here is to make a 45, 45, 90 special right triangle. Now, in order to do that, we start here with a square. And let's say that all of these angles we know in a square are 90 degrees. And for this case, we're just going to say each side is 10. Okay, a square has 4 sides that are the same and 4 right triangles. So if I take this square and I fold it in half, okay, on the bottom side here, let me trace this. On the bottom side right here, this is still 90 degrees. This side here is still 10. It didn't change. And this side over here is still 10. But this 90-degree angle up here and this one down here actually cut in half. They divided in half. So 90 divided by 2 is 45. So this angle is 45 degrees. And this angle down here is 45 degrees. So the 45, 45, 90 triangle actually comes from a square. And the thing is, I got to find this diagonal of the square. In order to do that, we use what we've already learned in the previous lesson about the Pythagorean theorem. So I can take the leg squared plus the leg squared. So 10 squared plus 10 squared. And that will equal my hypotenuse squared. I'll say h squared. Well, 10 squared is 100. So I have 100 plus 100 equals h squared. 100 plus 100 is 200. So 200 equals h squared. And we have to take the square root of that number. Now, when I take the square root of 200, I don't want a decimal, okay? Remember in the previous lessons, we kind of broke that down. Okay, 200 is 2 times 100. And I can take a shortcut here because I know 100 is 10 times 10. And this is a pair of numbers. Before we broke it down as far as we could go. But if I have a prime number and then a pair of numbers, that will be just fine. So this h equals, this circle group comes out front. So 10 square roots of 2. So this side right here will be 10 square root of 2. Okay. Now I want you to notice something here, that both of these sides are exactly the same. And this side right here takes this number and multiplies it by radical 2. And that's kind of our shortcut for this. So up here on this triangle, I'm going to label that. Okay, so I'm going to put an X here on this side and an X here on this side. Here's your right angle. Here's your 45, and here's your 45. Okay, so these two sides will always be the same. And this one, this hypotenuse, will take that side, which in this case is X, and multiply it by radical 2. Okay. Now, if you go this direction, you're just going to divide by radical 2. Okay, so down here on the bottom, we're going to look at some examples of this. So we can split this bottom part into 4 sections. And we're going to draw some triangles in that. So this first one here Put 11 there and an X and a Y there. This one we'll label the hypotenuse 25 radical 2. And for this one, the hypotenuse will be 12. We'll put an X and a Y in all of those. And this last one's going to be kind of our formula. So we'll put X, X. This is X radical 2. We'll fill this last one out first. I'll switch colors here. So if I am going from one side to the other, those are the same. Okay, they're exactly the same. And then you can go from either side to the hypotenuse. So let's say I go from this side to the hypotenuse. We're going to multiply by radical 2. Okay, which just means put it on the end. If I go the other way, if I go from the hypotenuse to a side, we're going to divide by radical 2. I'll show you what that looks like. It's a little bit tricky. Okay, so let's work these problems out. So again, I'm going from one side to the other. Notice the angles opposite are the same, so the sides have to be the same. So y is 11. When I go from a side to the hypotenuse, okay, from a side to the hypotenuse, I multiply by radical 2. So 11 times radical 2 is 11 square roots of 2. And we're done. That's it. So you really need to kind of know and memorize this triangle, and these will be very simple. Okay, so I know the sides are the same, but I need to go from the hypotenuse to a side. So when I go from hypotenuse to a side here, that's this direction, I divide by radical 2. So that is 25 radical 2 divided by radical 2. Hopefully you can see here, in this case, those radical 2's cancel out and you just get 25. So we divide it by radical 2. And then when I go from one leg to the other leg, those are the same. So this is 25. Okay. There's not a lot of work to show. Your work may be drawing down this reference triangle, if anything. Now this one's a little bit tricky here. I'm going from the hypotenuse to a leg. And when I do that, I divide by radical 2. So we're going to have 12 divided by radical 2. Now here's the issue with that. I cannot leave a radical 2 in the bottom. So in order to get rid of that, we're going to multiply by radical 2 in the top and in the bottom. Okay. And if this is something you need help with, please ask. I will help you out on this because it can be a little bit tricky. So in the top, we're going to have 12 radical 2. And in the bottom, square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. Okay. And then you have 2 divided by 2 is 6. So you get 6 radical 2. We'll try to do a bunch of these in class, so just ask about those. Okay, so that means that x is 6 radical 2. And the legs are the same, so y is also 6 radical 2. Okay, so that one's a little tricky. Just know that one of these, either the hypotenuse or the leg, is going to have a radical 2 in it. Okay. Okay, that is it for the 45, 45, 90. Please make sure that you know this formula triangle there. All right, moving over to the 30, 60, 90. Now you may have figured it out that a 30, 60, 90 comes from an equilateral triangle. In an equilateral triangle, all the sides are the same. In this case, we're going to label them 4. And all the angles are the same. And if all the angles are the same, they will be 60. Okay, so if I fold this in half, this angle up here gets split in half. Trace this here. So if that angle gets cut in half, half of 60 is 30. So this angle up here is 30. This side is still 4. This angle down here was 60, but nothing happened to it, so it is 60. This side right here got cut in half, so instead of being 4, it is now 2. Actually, this is a vertical line, so this makes your 90. So you have your 30, 60, 90 degree triangle. And I need to find this other side. Now, this other side is not the hypotenuse. Okay, but we can find it still using the Pythagorean theorem. Here's my hypotenuse right here. This is a leg, this is a leg. So we might say x squared, being this side, plus 2 squared equals 4 squared. Okay, 2 squared, well, x squared is still x squared. 2 squared is 4. 4 squared is 16. Now I'm going to subtract the 4 and get x squared equals 12. We still have to do the square root. And this one will break it down. We've got 4 times 3, and that is 2 and 2. So there's a group, and we have this left over. So you get x equals, the 2 comes out front, the 3 stays underneath. 2 square roots of 3. Okay. So this side over here, this height or this altitude, is 2 square roots of 3. Okay. So you should notice a couple things. This is your shortest side because it's opposite the shortest angle. So if I go from this leg to the hypotenuse, it's just double in this case. Okay. And then if I go from this leg to the altitude or the height, it is 2 radical 3. So it's just radical 3 times. So we're going to come down here again, and we're going to split it into 4 sections. Put some triangles in here. Now these aren't going to be drawn to scale. but we need to make sure that we're looking at the labels of these. And then over here, we will have the formula triangle again. And in my formula triangle, I just like to put 1 mark and 2 marks in your 90, okay? We forgot to write the formula triangle up here on the back side of this triangle. Okay, so going up here, this is your 90, this is your 60, and this is your 30. So we like to start with the shortest side, so we're going to mark that X. Going from the shortest side to your hypotenuse, you're going to double it, so that'd be 2X. And then going to this vertical line or this altitude, it would be X radical 3. And I remember the 3 because it's a 30, 60, 90. All those are divisible by 3. On the 45, 45, 90, that's radical 2. Okay, so coming into this formula triangle here, I always like to start with X on this short side. If I go from the short side to the hypotenuse, which is 2X, we simply multiply by 2. Okay, you double it. If you go from the hypotenuse to the short side, you just divide by 2. Okay, like up in our top example, it was 4 and then 2. That's just divided by 2. Now this altitude is X radical 3, or this height. And we still go from the short leg because it's easier. I don't like going between these two because it gets a little bit difficult. You can, but the formula isn't as easy. So if I go from the short side to this height, we're going to multiply by radical 3. And if I go the other way, from the height to the short leg, we're going to divide by radical 3. Okay, so on this example here, I'm going from the short leg to the hypotenuse. So that's times 2. So 5 times 2 is 10. Then I'm going to go from the short leg to the height. The short leg to the height, I multiply by radical 3. So 5 times radical 3 is 5 radical 3. Okay, again, there's not a lot to do there. Okay, here they give us the hypotenuse. So I like to go from the hypotenuse to the short leg, and to do the hypotenuse to the short leg, we divide by 2. So 5 divided by 2 is 5 over 2. Okay, we don't like decimals or mixed numbers, so we just leave it 5 over 2. It's less work for us. So this was divide by 2. Over here was multiply by radical 3. Then we go from the short leg to the height. We're going to multiply by radical 3 again. So 5 over 2 times radical 3 is 5 radical 3 over 2. Or you could write it 5 over 2 radical 3. Either way, that's the same answer. Okay, now this one's a little bit trickier. They give us this long leg, the long leg here, and I need to go to the short leg. When I go from the long leg to the short leg, from this height to the short leg, I divide by radical 3. So we have 9 divided by radical 3. Just like the radical 2, I can't leave that in the bottom. So we're going to multiply by radical 3 in the top and the bottom. In the top, you get 9 radical 3. And in the bottom, 3 times 3, or radical 3 times radical 3 is square root of 9. And the square root of 9 is 3. Now here, your 9 and the 3 can reduce. 9 divided by 3 is 3. So you get 3 radical 3. 3 radical 3. Again, that's a little bit tricky. So we'll do some of those in class. And if you have troubles, please ask. So this was divide by radical 3. And then the short leg to the hypotenuse, we multiply by 2. Short leg to the hypotenuse, we multiply by 2, sorry. So 3 radical 3 times 2 would be 6 radical 3. You don't multiply the radical 3 because it's kind of protected by that radical. You can only do it when they both share a radical. Okay. I'm going to put some practice problems up on Canvas for the 45, 45, 90 and the 30, 60, 90. Make sure you work through those before you get to the quiz, especially working through some of this radical stuff. I'll try to find another kind of help, IXL help on the radicals as well. As always, if you have any questions, feel free to reach out, and thanks for watching the lesson. I'll see you in the next one.